Okay, so the answer number one, the vertex of a central angle is located where? In the center. Very good. The measure of a central angle and its intercepted arcs are what? The same. Very good. The vertex of an inscribed angle is located where? What? On the edge. Very good. The measure of an inscribed angle is equal to half the measure of its what? Okay. Yes, I understand where that's coming from, but I want you to think that it's equal to half of its intercepted arc. The intercepted arc is the same as the central angle, though, right? So technically that's the same, but you won't always be given a central angle to find the inscribed angle. Okay, 3 new ones. We really haven't talked about this, so these are guesses, right? What's the measure of a semicircle? 180, very good. What's the measure of a minor arc? Could be 90. It just has to be less than a semicircle, which would be less than 180. So what would be a major arc?
Greater than 180.
Greater than 180, very good. Okay, did you already have a time to do number 1 and number 2? Okay. What do you think the measure of arc AB is?
That question was number 6 again.
Number 6 is less than 180.
70.
70 degrees. How many of you had 70 degrees? Good. The measure of arc FTE. F, now be careful. I'm hoping that what you did is you went all the way around from F to T, all the way around to E. What's a full circle? 360, right? So FTE would be how big?
260.
260. Very good. I'm not sure why that 300 keeps popping back up. I think I've deleted it like 12 times. That's okay. All right. Are we ready for 3 and 4? Or do you need a minute? Need a minute? Okay. Okay, so remind me, what is the measure for IHG? Again, watch the symbols on these.
300.
It's asking for the arc of I to H to G. What did you get? 300? And then this symbol, the symbols are the things that are going to get you this unit. This one says, what's the measure of angle? G, H, I. And that would be your 30. Why is that one 30?
Because
Why is it not 60?
it's half.
Why? Where's your vertex?
It's on the primary.
Good. The vertex is on the edge. So we take the intercepted arc, which is 60, and we cut it in half. So that means that this one inside would be 30. Okay? Okay. Number 4, how big is arc? Notice the symbol, L to K to J.
250.
Because a full circle is how big?
360.
Good. So this one is 250. And then the other one asks for angle. Notice the symbol difference. J, K, L. What did you get? 55. Is everybody okay with that? Any questions about those? Okay. 5 and 6. Do you need a minute? Yes? Y'all smell that? Smell weird?
Smells like circles.
Smells like circles?
It does. I can't smell it.
Huh? You can't smell anything? It just smells weird.
I don't
And I don't smell things, so it's weird to smell things. You know what I'm saying? Like I don't have a good sniff. Maybe it's just me. Okay, recording. Okay, how big is arc LN?
42,
42, absolutely. Why is it 42?
because you add 21 to the 21 degrees.
Be good. Because right here they told me that this angle is 21 and the vertex is on the edge. So to get back up to the arc, wouldn't I multiply by 2? Good. And then how big is arc NML? That's all of this, right? What did you get for that one?
318.
318. Very good. On this number 6, that's confusing. They didn't give me any numbers. What's 180? Arc GE.
Yeah, RG.
Very good. She's absent. Okay. And then the angle that they're asking for is angle EFG. So if this arc is 180, how big is that angle in there? 90 degrees. Very good. This is what you should have done yesterday on that fourth circle. If the inscribed angle was 90, how big should the central angle be? Okay? Good. All right, the back page right here, this is part of your homework. Don't forget about that back page being part of your homework. So let's go back to the front part, talk about some notes. Somebody remind me, what is a minor arc? What is
180.
good? Less than 180 degrees. Very good. Less than 180 degrees. And then it's just going to be a little piece. What's all the way around the circle called? Uh-huh. What would it be called though?
Circumference?
Circumference. Very good. Circumference. Okay. And what would a major arc be?
More than 180.
More than 180, greater than 180. Okay, so that means your arc is going to start at a spot and it's going to go around more than halfway. And then how big is the semicircle?
Equal.
Good, that one is equal to 180 degrees. So that one is just going to go halfway around. And then this definition right here, I'm going to let you copy for a second. This definition is just what we talked about yesterday. In a circle, the degree of the measure of an arc is equal to the measure of its central angle that intercepts the arc. That's just what we did on those yellow circles yesterday. Example 1, you're just reading it. Who would like to read this one? Okay.
In circle R, measure A or B.
Okay, hold on, be careful. I'm teaching you right now, okay? So go back. The M stands for measure. What's that other little symbol right there?
Measuring,
Angle. Okay, good.
measure angle A or B equals 42, and AC, line AC is a diameter. Find measure AB,
Okay, this is arc.
arc,
Okay,
and measure arc ACB.
very good. So on this unit, the thing that's going to get you are the little symbols that go before. Because sometimes they're going to be talking about angles, sometimes they're going to be talking about segments, and sometimes they're going to be talking about arcs. So you really need to pay attention to what they're asking for. What does that little M stand for again?
Measure.
Measure. Okay, so please make sure that you're very, very careful how you read these questions. Why is it important for them to tell me circle R?
Because there's multiple points.
What does it mean, circle R? What's R?
The center.
R is the center. It tells you for sure. We're going to have a point in time where I'm putting points inside of circles and they're not going to be the center. Are you with me? So by them telling me circle R, you need to read that R means it's the center. Because we name a circle by its center point, don't we? Okay, so start looking for things like that. And then it tells me that the measure of angle ARB is 42. Well, if the angle is 42, how big is this arc right here? 42, because it goes to the center, right? That's what we talked about yesterday. And then why in the world would they tell me that AC is a diameter?
So you know it's 180.
Ah, so I know that this whole side over here equals 180 degrees, and this whole side over here equals 180 degrees. So how would I find out how big this angle is?
By subtracting 42 from
Good, 180 minus the 42,
137.
138.
Oh, yeah.
That's okay. Now, did they even ask me for that? What they did ask me to find is to find the measure of arc AB. Well, we already answered that one. That one's 42 degrees. Everybody agree? And I'm going to erase just so we can see some stuff over here. And then the next thing they say is, well, how big is arc ACB? Go in that order from A around to C and around to B. Well, what's a full circle?
60.
So how would I find out how big ACB is?
60 minus 40.
Good, 360 minus the 42. Excellent job. So would that be 318 degrees? Okay, I'm going to give you a second. I want you to do 1, 2, 3, and 4. All right, so it says find the measure of each. The first one they asked me for SCT. How big is SCT? What did you do to find it? 90? Do you agree?
75.
75. Why? How do you know?
We add the 60.
180.
That's the diameter, right? And how big is a full diameter?
180.
180. So we did the 60 plus the 45. There's 105, so 180 minus the 105 gives me 75. So this one would be 75 degrees. The next one is asking for SCQ. SCQ. How big is SCQ? 90 degrees. How do I know that one's 90 degrees?
Because it has a little mark right there.
Good, because it has this little box. Excellent job. Okay? The next one is asking for SCU.
135.
Why?
Because because from number 1 you add 75 to 75 to 60 and you get 135.
Excellent job. 135 degrees. Fantastic. And then the last one is asking for QCT. QCT. Question. How do I know whether it is this angle or this angle here? Technically, it doesn't, I don't know. What we're going to use is we're always going to ask you for the smaller one. Okay? So if you're not sure which one they're asking for right now, we're always going to ask for the smaller one. So probably what you did is you said 90 plus 75, right? And got 165, is that true? Okay, so I just wanted to make sure we had that conversation. I'm going to always ask you for that smaller one right now. Okay? Well, what's a full circle?
360.
So 360 minus the 165 would give me what the other side was.
Okay.
Okay? Good. I'm going to give you just a minute. I want you to do 5 through 10. So right here it tells us that the measure of angle BOA. So angle BOA. Where's the vertex?
Oh.
O, which is the what? The center. So that means this is a central angle. So if the angle is 44, how big is the arc?
88.
44.
44. Why? Because it goes to the center. Remember, it's half or double whenever it goes to the edge of the circle. When it goes to the center, they're the same. So the measure of arc BA would be 44 degrees. Well, then it says, well, hold on just a second. How big is arc CD?
44.
Why? How do you know it's the same?
Opposite interior angles.
It's vertical. Very good. These angles right here are across from each other. These are 44 degrees. It goes to the center, which means that this arc right here would be 44 degrees. Excellent job. Okay, then it says, well, how big is arc B to C to D? 180, because this line right here is called a what? A diameter. Very good. And a diameter equals 180 degrees. Perfect. Thank you. Okay. And then the next one says, well, how big is arc BC? Well, BC is right here. How would I find that one?
180 minus 44.
Good, 180 minus the 44 gives me what?
136.
136. Excellent job. So circles are easy?
Yeah.
Yeah?
Now they are.
Now they are
Easier triangles.
easier than triangles, okay? So how big is the measure of angle or arc ACD? So A to C to D. What's a full circle? And what do I need to do? Subtract what? Okay, so let's look at the picture again. Okay, it's asking me for the arc from A to C to B. So I would do what? 360 what? Minus the 44, which is the little piece that I have right here, correct? And that would absolutely give me 316. Is that true? And then the last one says, well, how big is AD?
136.
136. Excellent job. Okay, flip your paper over to the back top, and I want you to take a look at that top one. And tell me what you think. Whoa. Fun? I think so too. What a great description.
Oh, sorry.
Give me ideas. What is your brain thinking? Where would I start? What would I do?
4x plus 15x plus 3 plus 7x minus 5 equals 180.
How do you know they equal 180?
Yeah, it's on the dot diameter.
Because right here they tell you that those lines are diameters, right? So EB is a diameter, which means that's half of a circle. That's a semicircle, which means that it equals 180. Absolutely. So fix me if I do this wrong. 4x plus, is it 15x minus 2?
It's 4x plus 15x plus 3.
Oh, plus 3.
Plus 7x minus 5 equals 180.
Minus 5 equals 180. What would you do first?
Put all the x's together.
Good, let's put all the x's together. So I have a 4x, a 15x, and a 7x. I believe that's 26 x's, isn't that true?
That is,
Good. And then I have a plus 3 and a minus 5.
Minus 2.
Minus 2. And that would be equal to 180.
You add
Now
the
what?
2, add the 2.
Good. We're going to add 2 to both sides. So now I have 26 x's, and that's going to be equal to 182. Divide by 26. Y'all are professionals here. So how big is x?
7.
7. So x is 7. So now let's go see, did we answer the question? Here it says, what's the measure of angle? ERD. This one's ERD right here, right?
So that means we just plug 7 into 4x.
Good. So ERD is 4x. So that means 4 times 7 equals what?
28.
28 degrees. Excellent job. And on the next one it says, what's the measure of angle CRD? I believe this is CRD up here, right? So that's 15x plus 3. Well, that means 15 times 7 plus 3.
And 4x. I mean 4.
No, just that part. No 4x's.
Oh,
It's just the 15x plus 3, which I believe is 108. Is that right? 108. Are we okay? All right. So here's where the difference comes in today. Okay? I can measure a circle in degrees. How big is a full circle in degrees?
360.
360. But is it true that I could also try to take a ruler to measure something round? Is it going to work very well? No, but I could take something like a pipe cleaner or string and wrap it around, correct? What is that called when I wrap something around a circle? Circumference. Absolutely. Because then I could unwrap that pipe cleaner and put it on my ruler and find out how long it is. Okay? Sometimes you want a measurement in degrees. And sometimes you want to know inches or centimeters to find material you need to make something with. Are you right? Are you with me? The good news is that if I combine those two things together, I can find either or. The two totals of a circle. Total of a circle is 360 or circumference, right? What's the formula for circumference? 2 pi r. 2 pi r. Very good. So when we're doing that, all we're going to do is set up a proportion. And on the bottoms are the two totals. You just told me the degree measure of a circle was 360 degrees, right? And then you told me the circumference formula is 2 pi r. But Ms. Ramsey, when do I use this? You use this when they ask you to find the length. Circle the word length really big. When you see that word length, you're going to set up this formula. Okay? Right here at the top, this is the length. This is like I'm measuring with a ruler. Over here are the degrees. That's what we just did. How big is an arc? What is the measurement? This is talking about the degree of the arc, like what we just did. Okay? So let's take a look at this first one and set it up. First off, I see that it wants me to find length. That's my key that I need to set up a formula. Okay? And when I set up that formula, what I'm going to do is I'm going to set up a proportion. What's the total of the circle all the way around in degrees?
360.
360 goes on the bottom right here. What's all the way around not in degrees? What's the formula? 2 pi r. What's r stand for again?
Radius.
Radius. It's asking me to find the length. That's this number right here. This is asking for the length of an arc. That's what we're trying to find. That's x. So what goes over here? The degrees of what I want. Well, let's go back and read. It says in circle R, the measure of angle ARB is 135. And RB, what is RB? What is it though? It's my radius. Oh, so right here where I have the R, I can plug in an 8 because that's my radius. Are you with me so far? And AC is the diameter. Now it wants me to find the length of arc AB. How big is arc AB? How big is the arc AB? It's 135 degrees, but they're asking me for the length of it. So the degrees of it is 135. So I want 135 degrees out of 360 degrees. And I don't want the whole circumference, I just want the part of the circumference. Okay, I want you to understand this one step better. In your calculator, I want you to push 135 divided by 360, math, enter, enter. 135 divided by 360, math, enter, enter. 3/8. That means I don't want the full circumference, I only want 3/8 of the circumference. Are we okay? I want you to comprehend what we're doing. I want to find 3/8 of the circumference. I don't want the whole thing. The good news is all I have to do is cross multiply right here. Okay? So in your calculator, push 2 pi 8 times 135. So you're going to put in your calculator 2 pi 8 times 135. And somebody tell me, what do you get?
6,785.84.
Okay? And when I cross multiply the other way, that's going to be equal to 360x, correct? Now what would I do?
Self-words.
How?
Divide.
Good.
So
Divide by 360, right? So what's 6,785.84 divided by 360?
18.85.
18.85. That means that this arc over here is 35 degrees, and if I were to measure it with a ruler, it's 18.85 units. 18.85 inches, 18.85 centimeters, whatever. If I measured it with a ruler, it's 18.85. But the number of degrees is 135 degrees. Are we okay? I want you to try number 1. Let's see what we did. Well, first off, what's the key word? What's the thing that like made the light bulb go off? Length. Okay, so you circle the word length, and that tells me to do what? Good. Set up the formula. What goes on the bottom right here? 360. What goes on the bottom right here? 2 pi r. Do we know the radius? No? It's what? How'd you get 12?
So the diameter is 24.
Good. Up here it told me the diameter is 24. That means that my radius would be 12. So this number right here should be a 12. Okay. Well, then they want me to find the arc DE. So I need to find out how big that arc is right there. But it tells me that angle DOE is 120. Where's the vertex? In the middle. So how big is this arc right here? 120. So because it goes to the center, the arc and the angle are the same. So that means my degree right here would be 120 degrees. Is that true? And I'm looking for the length. That's this one right here. So then when I cross multiply, what did you get?
25. Oh, wait, no.
Yeah, the answer is 25.1. But then it should be 360x is equal to, what is it when you multiply those out? Like 9,000 something? Is it
9,047.7.
9,047? And then we would divide by 360? And you get 25.1. Is that true? How many of you had it right? Good. All right, so I'm going to come around and help. Okay, so on number 2, did you set it up as x over 2 pi 12, 210 over 2 360? And you got 44? Okay. Then on number 3, you should have set it up as x over 2 pi 12 and 45 over 360. And you got 9.4. Is that true? How many of you got 9.4? Good. And then the last one, you put it as 135 over 360 and you got 28.3. We're good? Good.